This is part 78 of C# tutorial. In this video, we'll discuss sorting a list of complex types. This is continuation to part 77, so please watch part 77 from the C# tutorial before proceeding with this video. In part 77, we discussed sorting a list of simple types like list of integers and list of strings. .NET Runtime environment knows how to sort a list of these simple types because these simple types have already provided the implementation for this interface iComparable. So this interface has got one method compare to. So basically this is the method that we use to tell .NET Runtime environment how to compare objects of a given type. So that's why, since we already have the implementation for this iComparable interface for these simple types, .NET Runtime environment knows how to sort them. But when it comes to complex types like customer, if you look at our customer class at the moment, this class doesn't provide the implementation for this interface iComparable. And look at this. This class has three properties at the moment: ID, name, and salary. And if you have a list of customers, and then if you ask the .NET Runtime environment to sort them using that sort function, how will the .NET Runtime environment knows how to sort that list? Should it sort based on the ID property or the name property or the salary property? It will have no idea. We will have to tell that to the .NET Runtime. So, and how do we do that? By providing implementation for this iComparable interface. Okay, so let's go ahead and do that. But before that, look at this. We have this customer class with three auto implemented properties. Within the main method, we are creating three instances of this class: customer 1, customer 2, and customer 3. And then we created a list of customers, and then to that list we are adding those three customer objects. Now let's go ahead and invoke the sort function. Okay, and let's build this by pressing Ctrl+Shift+P, and look at this. Build succeeded. So we don't get a compile time error, but then when I run this at runtime, we get an invalid operation exception. Failed to compare two elements. And look at this, at least one object must implement iComparable. So we need to provide implementation for that iComparable interface. So let's do that now. So let's make this class inherit from iComparable interface, iComparable of customer. And if I right click on this interface and go to the definition on that, notice that this interface has got one method, compare to. So let's copy the signature of this interface, and in the class where we provide the implementation for the interface members, we need to use this public access modifier, and the type here is going to be customer because we are going to compare an instance of this class with this customer object. Okay, and how do we get access to an instance of this class? By using this keyword. Okay, and look at the return type of this method. It's an integer. Okay, and this return value has got some meaning. Okay, so if that number that we are returning, if it's greater than 0, then the current instance is greater than the object that we are comparing with. Okay, similarly, if it's less than 0, then the current instance is less than the object that's being compared with. In case if it's 0, then both of them are equal. Okay, so let's say we want to have these customer objects sorted by their salary. Okay, so if that's the case, then this dot salary, if that is greater than the other objects dot salary, if that's true, then let's go ahead and return 1. Else if, let's copy the same condition, if this dot salary is less than the other object's salary, in that case I'm going to return -1. Else, if it's not greater or if it's not lesser, then we know for sure they are equal, in which case return a 0. That's it. So we have provided the implementation for this compare to method. Okay, so let's go ahead and run this now. But before we do that, let's print the list of customers. So we are sorting the customer objects based on their salary. So before we invoke the sort function, let's print the list So let's use a for each loop for each customer. See in our list customers, let's print their salary, and let's print a message on the top stating this is before sorting. So before sorting. Okay, and then we sort it, and then let's print the list once again, but let's say the text here is after sorting. Let's put a semicolon there and a semicolon there. Alright, so let's go ahead and run this now. So look at that, before sorting 4,000, 7,000, 5,500 are the salaries, but here we have them in ascending order, 4,000, 5,500 and 7,000. Okay, so the sort functionality is working now as expected. Now if I want these salaries to be in descending order, then it's very simple. All you need to do is invoke the reverse function. So list customers dot reverse. So we run that, we should have salaries in descending order. Alright, now look at this here in this compare to function. The salary is of type integer. Okay, and if you look at the int type, that's a structure, and this int has already provided an implementation for iComparable interface. So obviously this iComparable interface has got this method compare to. So this compare to method for the int type has already provided implementation. Can't I use that implementation here because the salary is of type integer? So instead of writing all these lines of code, what I basically can do is I can achieve that in one line. Return this dot salary. Okay, so return this dot salary. Salary is of type integer, and integer type has already provided implementation for this method compare to. So I'm going to use that and then compare that with the other object's salary property. And if we highlight over this, look at that, it's returning an integer back. So now we have less code and the behavior should be the same. Okay, alright. Okay, at this point, if you look at this customer class, we are sorting the list of customers based on their salary. Okay, but this customer class has got several properties like ID, name, and salary. Now let's say my requirement is I don't want to sort these customers by their salary. Instead, I want to sort them based on their name. If that's the case, the default sort that is provided by this customer class is useless. So I need to change the implementation. So instead of saying this.salary.compare to, I can say this.name.compare to with other object's name property. So in this case, when we invoke sort, then the customers are going to be sorted by their name. Okay, so let's actually print the customer's name there, and similarly here customer's name. So let's run this now, and look at that, they are in that order, but here they are in descending order because we asked it to be printed in descending order because we invoked reverse function. So it's working. Here we own this customer class, so we can change it the way we need it. But in real time, there may be several instances where you don't own the class code, but you want to change the default sort functionality provided by that class. You don't want to use that, but instead you want to sort objects of that type, using another property. So how do we achieve that? That's when we provide implementation for this iComparer interface. So you can create your own class, make that inherit from iComparer interface, iComparer of customer, and then that interface has got this method compare, and you provide the implementation for that interface. So let's go ahead and undo these changes. Okay. So at the moment, this customer class is still sorting the employees based on their salary. That's the default implementation provided by the customer class. But in my project elsewhere, I want to sort customers based on their name. If that is the case, what I can do is I can create my own class. So maybe let's call this class sort by name. You can give it any meaningful name you want. And then we are going to implement this iComparer interface. So iComparer of customer. and this interface has got one method. So let's right click on that and go to the definition. So it has got this compare method. So I'm going to copy the signature and then paste it right there. So let's have that public access modifier, and the types here are going to be customer. So that's one customer object, and this is going to be the other customer object. Okay, and then we want to have these customers sorted by their name. So return x dot name dot compare to. Again, string type has already provided the implementation for compare to method, so we are going to use that implementation here. Compare that with y dot name property, and then return the value that this method is returning. That's it. So now that's the first step. Provide the implementation. Basically create your own class and implement iComparer interface. The next step is to create an instance of this class and then pass it to the sort function. So here we are using the default sort provided by the customer class, but if you don't want to use that, what I'm going to do here is sort the employees, customers, based on their name. So I can create, sort by name class, and let's call it sort by name equals new sort by name, and then let's pass that there. So sort the employees, customers by name, and then let's use this loop and print them. So sorting by name. Okay, so let's go ahead and run this now. So here, before we have sorted it by salary, the salaries are like that. Then we have after sorting by salary, they are like that in reverse order. But here we are sorting by name. We can't really see that, but let's do this. Let's actually print customer name instead of salary. So at this point we should have customer names in ascending order: M, P, R, Mark, Pam, Rob. Okay. Alright, now the sort method on the list instance has got several overloaded versions. So we have seen how to use this version which doesn't take any parameter. If we use this method, then the default sort functionality provided by the class will be used. But then if you want to override that, if you want to provide your own sort logic, then you can create another class that implements iComparer interface, and then create an instance of that class, pass it as an argument to the sort function. Okay, so that's when we use this overloaded version where we pass iComparer. But there is another overloaded version. If you look at this, there is something called comparison of customer. So what is this comparison type? Is it a class? Is it a delegate? What is that? So let's actually look at that. So comparison of, let's say, customer, and now this is actually, look at that, it's actually a delegate. Okay, and delegates are very important and very useful. In our next video we'll discuss how to use this overloaded version of sort which expects a delegate of type comparison to be passed as an argument. Alright, that's it for today. Thank you for listening. Have a great day.